Professor Tim Noakes is the Discovery Health Chair of Exercise and Sport Science at the University of Cape Town, as well as the Director of the UCT Medical Research Council Research Unit for Exercise Science and Sports Medicine, and also the co-founder with Morne du Plessis of the Sports Science Institute of South Africa. He has published more than 450 scientific publications. He has been cited more than 12,500 times in the scientific literature. He has an H-index of 61 and is rated an A1 scientist by the National Research Foundation of South Africa. He is the celebrated author of The Lure of Running, which internationally is considered the most comprehensive Bible on the understanding, enjoyment, and improving performance in sport. He has completed more than 17 marathons, as well as, most importantly, 7 Comrades marathons. He will address the Congress on the subject of historical and scientific reasons for the success of African distance runners. And after his speech, you might even get a few recipes for, as of late, Prof. Noakes has also done quite a lot of that. I give to you Professor Tim Noakes.
Thanks, Gary. Thank you, Gary. It's a great privilege to be here. Thank you all. Thank you all for what you do for running around the world. The Comrades Marathon was probably the single most important event in my life and really changed my life in a way that I know changes so many people. And when people run marathons, they're different when they finish. And I thank you for putting so much time and effort into making it a safe sport and a more enjoyable sport for so many people. I was asked to talk about the historical and the scientific aspects of marathon running, and particularly the role of Africa in that development. And I think everyone knows that Africa is the home of the sprinters and the distance runners. And I've put a few labels to countries in East and West Africa. And of course, it's the West Africans who provide most of the sprinters globally, whereas it is the East Africans and the South Africans and the Northwest Africans who provide the distance runners. It all begins with Abibi Bikila, and I won't necessarily go over the whole story there, but there are some interesting points. On the left, you will see him running barefoot in the 1960 marathon because his shoes didn't fit, and he changed the world about there. And if you watch him when he finishes the Tokyo Marathon, he set the world record. He finished 3 minutes ahead of the second runner and spent 3 minutes doing calisthenics just to make sure that he indicated how fit and healthy and strong he was. He also ran that race 5 weeks after having his appendix removed. So an astonishing athlete. This graph shows the distribution of different countries and where they are most successful in different activities. And it's a complex slide, but it shows that if you look from the 100 to 400 meters, almost 100% of all best performances up to about 1990 were by West Africans. And then you can see the West Africans become less effective in the longer distances, and the Kenyans become particularly dominant in the 3,000-meter steeplechase. These data are dated because I suspect that the Kenyans now are probably hold 60, 70, 80% of the 42K best performances. And we look at the Europeans, they tend to get better the longer the distance, but are not really as competitive from 1,000 meters up to 10 kilometers. What's unique about Africa, this is a lovely graph, a drawing, and it shows that the Rift Valley produces runners. And we will focus more and more on the Rift Valley and the Kenyans' contribution. I think the first time that people started to question what was happening in Africa were the '88 Seoul Olympic Games, when Kenyans won these 4 gold medals. Now, for a country with 24 million people, the probability of that happening is 1 in 1.6 billion. So it just doesn't, it's impossible. It cannot happen by chance, or it's absolutely unbelievable. And so people then started asking questions about why were the Kenyans so successful. In the same year, this was their performances, the rankings in distances from 800 meters to the marathon. And of course, it will be changed today. I'm just going back to the historical. This is when people started to realize that there was something different about the Kenyans. And in the World Cross Country Championships, this were their performances. And you can see that the Kenyan senior men won the competition for 12 years between 86 and 97. But what is really interesting is if you go back to when it starts in about 84, when for the first time the Kenyans start training as a group, that the coach at that time in 1984 brought all the Kenyans together before the cross-country championships, and they trained together for a period of about 3 weeks, and the survivors were sent to the World Cross-Country Championships, and it was a day off for them because they trained so hard, and they'd run themselves each into the ground, so the survivors went. And that became the model for success of the Kenyan runners, and it applies today before the Olympics, that there is basically a race-off before the Olympics to see who's going to get into it, the race. And I'll talk perhaps a little bit later on about the different mental attitude that the Kenyans have. The Kenyans do not race for time, they don't race for distance, they race to win, and that's the philosophy that is totally different to the European way of running. The Europeans, we worry about the distance and the time. They have no interest in time or distance, it's who comes first, and that's it. So it's a different philosophy. If you look in the Rift Valley, the different colors give you the contribution of the probability of you being a great runner if you come from the different areas. So if you come from the yellow area, you have zero chance of being a great distance runner. So that's the west of the country, sorry, the east of the country, and it's sea level and it's hot. But when you get up to the Rift Valley, then you suddenly see that your probability, you might have a normal chance, but here you've got a 1 to 5 times better chance of being a world-class athlete. But if you're the Nandi tribe, you have something like 23-fold greater chance, which is just ridiculous. In medicine, we say if your risk of something goes up 2-fold, that's huge. 23-fold difference is astonishing. So something is very strange in that part of the world. So there are a couple of hypotheses for why this should be, and I'm going to go through them and give you what evidence there is either way. Firstly, that it's genetic. Secondly, that it's early exposure to running in childhood that explains their success. Third is that they are much more economical and that they are slightly smaller and they may have different biomechanics. The fourth is that their muscles are better, that they're better able to use lactate or carbohydrates or fats as a fuel. The fifth is that they eat a different diet than the rest of the world. The sixth is that they train high and they live at altitude and they train at altitude. The seventh is that they're motivated to achieve economic success. And the eighth is possibly other reasons which we could consider. I just want to draw attention to this guy running. We've just had the privilege of testing 15 really good Kenyans, not the very, very best, not the Olympic champions, but the next grade of athletes in Cape Town. And that was some of the studies that we were doing. And it's the most complete study ever done of any group of athletes in the world. And it leads in from what I'm telling you, but we don't yet have those data. So, Andrew Bosch is a colleague of mine, works in our department, and he was really the first guy in the world, as I know, to do a trial in the laboratory looking at black and white runners in South Africa and using that as a model to try to explain why black runners are better than white runners, particularly as the distance gets longer. And so this was the first study, and this was what he just went out. He was living in Grahamstown at the time, and he went for a group of marathon runners, and this was the data that they had. And they all ran the same time. The average finishing time was the same, but what was interesting was that their marathon speeds were pretty much the same. On the treadmill, they ran pretty much the same. Now, this is the value that people always talk about, your ability to use oxygen, which I'll show you is meaningless. If you're going to be good, you have to consume a lot of oxygen, but that doesn't really predict much. And you'll see that actually the white runners had a higher value, so if you believe it's important, you'd think the white runners were better, but they weren't, they were matched. The big thing is the mass. I'll keep talking about this. The size of the runners is critically important, and of course, they're also smaller. So here we had a group of runners who ran the same time in the marathon, but actually the white runners had more potential. So in fact, potentially were underperforming. And he had them run on the treadmill at their marathon pace. And what he found was that for the black runners, they were running at a slightly higher oxygen consumption, and their heart rate was slightly higher, and they were running at a higher percentage of their maximum, which is really interesting. So in fact, they were running harder to get the same result. They were actually running harder, which is most interesting because one would have thought that it wouldn't have been different because their performances were different. So what it seemed to suggest was that these guys were actually slightly better, less good physiologically, but they actually they raced harder. So that would have been the conclusion from that study. And the next thing, he was the first to look at the skin temperatures and the body temperatures of these athletes. And he showed that the black runners maintained a lower temperature. So here you see the white runners, this is their body temperature, was higher. And this is a crucial factor, and we completely ignored it at the time. Because I'm going to show you that the body is a very complex organism. And one of the keys is you must keep your body temperature low during exercise if you want to perform optimally. So we didn't know that in 1990, but that was interesting. And the skin temperature was different, that the pectoral skin temperature, that's the upper body temperature, was higher actually in the black runners than in the white runners. But the lower leg temperature was different in the two groups. And so that the black runners, and there was their mean skin temperature. And so the key was that black athletes ran at a higher percentage of VO2 max, so they should have been hotter because that determines how you should be hotter if you're running harder. But they actually maintained lower rectal temperatures and higher body skin temperatures during the simulated marathon. So this was not a race, but that was the conclusions, that there seemed to be some subtle differences. And what amazes me as I go through this work is how easy it was for us to show differences between black and white runners. It was astonishing because science is really difficult to find differences, but we were able to find them in all our studies. The next study we did was we looked at the best black runners in South Africa at the time, and there were some really good runners. This was the 80s when South Africa was probably ranked second or third in the world at distance. But who could we compare them to who were white runners? We could only compare them to our best milers. And we found a group of mile runners who were really good, and they were good up to about 10,000 meters. And what we found again was that the white runners were much bigger and much heavier, and their oxygen consumption, which again I've told you is a variable that we think is important, was exactly the same, so that didn't seem to be different. And the speed that they reached on the treadmill, which is a really good predictor of ability, was pretty much the same. So what this tells you is that these guys, let's go back. These guys, the black runners who are distance runners, could produce as much power on the treadmill as these guys who were milers, who are much more powerful. And that was really astonishing. It opened our eyes to the probability that the black runners have incredible power and speed, even though they're endurance athletes. So that was the first interesting finding there. We then compared those athletes to the published data for US elite runners who were studied in the 1970s and who were the best group of runners that had been studied up to that time. And what you see again is that the mass is big. There's a huge difference in mass, that the black runners are at least 10 kilograms lighter. And that's a factor that we'll keep coming to all the time, that European runners generally are just too big. And it makes a huge difference ultimately in the outcome. And then we looked at their body skin folds, that's the level of fatness, and there was no difference, which is interesting. There was no level difference of their fatness between the groups. But their girth measurements were also much bigger in the white American runners. So you can see that all the thigh, the calf, the arm, the forearm, much bigger in the white runners than in the black runners. So the black runners are smaller and lighter and less muscular, but they're not less fat. The fatness is pretty much the same. And then they have smaller femurs. The femur, which is the big thigh bone, was also different. And then if you look at what we call anthropometry, which is how we classify ourselves as either how much fat, how much muscle, or how much leanness, how much tallness do we have, and what we find is, I mean, this is well known, that marathon runners fit in this small little area here, which is very ectomorphic, meaning very linear, with no fat and no muscle. But I mean, that doesn't really tell us, but that would perhaps be very obvious. So that's where they fit as athletes. If they were weightlifters, they would fit up here, for example, very, very muscular. If they were long-distance swimmers, they'd fit on the fat side and so on. So that's where they fitted. Now, the next thing was then had these guys looked at their records for how they ran at different distances because we wanted to see what was the endurance performance of the two groups. Now, do remember that we're not really matching black and white athletes. We're matching long-distance runners to middle-distance runners. And so perhaps part of what you find is what you'd expect. But this is what we found, was that as the distance went further, sorry, this should be up to the marathon. This would be 1 mile and then probably 5, 10, half marathon, full marathon. What you see is that the two groups are pretty well matched at the shorter distances. Perhaps the white runners are a bit faster, but the curve falls off more quickly in the white runners, as you'd expect, because they're trained to run the mile and the 5 kilometers. But the black runners are able to sustain a higher percentage of their maximum for longer, and so we call that superior fatigue resistance. And then that's the running speed. So the top one was their amount of oxygen they were using as a percentage of their maximum, and there you can see the difference, that the running speed, the black runners were able to maintain a much higher running speeds the further they went. And the differences were significant. And so to summarize what we found, that in the middle distance runners who were white, we found that they had the same aerobic capacity. When we did muscle biopsies, and that was the funniest part, because William Matola, I don't know if he's in the audience, great South African runner, and Matthews Tamani, who were two of the guys in the study, when they heard that they were going to have a muscle biopsy, of course, we have to get their consent. They just ran. They ran to the hotel. It was so funny. The next we found them at the hotel. They weren't interested. But a few of the guys were keen to have their muscle biopsies performed. And we found that it was quite interesting that the long-distance runners had a lot of the type 1 muscle fibers. And we normally would think that you needed 80 or 90% of those fibers, but in fact they didn't. They had much less. And again, you can see the height and the weight is different, and the fatigue resistance was different. So, one of the problems is, how can you compare people who don't run the same in the first place? It's very difficult to say. To say this is a white-black difference, you can't say that. All you can say is that this is what we found. It may be due to racial differences. It might just be because we're looking at different athletes. But if you look at other great runners, Daniel Komen, who held the world record, I think, for the 5 or the 10,000 meters in the 90s, he could run the mile almost as fast as Sebastian Coe, who was the world record holder, which is astonishing. And so he was one of the athletes who really shows what these guys can do. They can run so fast at these short distances, and at the longer distance, they're able to sustain faster running speeds than people like Sebastian Coe. And of course, Sebastian Coe was not trained to run 5,000 meters, whereas Daniel Komen was. I understand that. However, the fact is that Komen could still run the mile almost as fast as Sebastian Coe, which is really astonishing. And that begins to give us an idea of some of the differences. Now, this is Haile Gebrselassie, how he paces himself during a 10-kilometer race. And you may or may not have seen this phenomenon, but it's really important because what he does, these were his 3 world records, 95, 97, and 98. And you can see he slows down slightly up to 9 kilometers, and then guess what happens? He speeds up. Now, what does that tell you about what we understand about physiology? It tells us we know nothing about physiology. Because he's tired. He's meant to be tired, but he's not tired because he runs faster. And that's the pacing strategy. And I will then introduce you to this novel idea that we developed, that the brain regulates exercise performance, not the muscles. It's not because the muscles get tired that you slow down. You slow down because the brain regulates the performance. And so what's happened is he is able to increase his performance near the end, and that's what makes him a great runner. And we don't really discuss that. So Haile Gebrselassie, what makes him different is what he does in the last kilometer. That's the key difference. And when he runs the marathon, as I'll show you, it's also the same. So there's his performance. He becomes the world's best distance runner. Understand, when he was the best distance runner, only after he's raced 8,000 meters. But up to that point, they're all the same, but then he becomes the best. So what I'm introducing there is the pacing strategy is something we have to consider, and how can people speed up at the end? Because that's we haven't measured that. So then another study we did, we again found that black athletes had superior fatigue resistance, and on this model, we had them run at 92% of their maximum capacity on the treadmill for some time, and then for as long as they could, and what you see again is that the black athletes were able to run longer than the white athletes. And their blood lactate concentrations were lower. And this is uniform. There is no study in the world which has ever shown that black athletes have higher lactate levels than white runners. Never happened. They always have lower blood lactate concentrations. And it's never been explained why. And we absolutely don't know why. I don't think it's got anything to do with performance. Sorry. I don't think it's got anything to do with performance. It's a biological difference, which we really need to understand. But it's very, very clear that it's the easiest thing you can observe in these athletes. So even though the black athletes ran further on this treadmill test, they had lower blood lactate concentrations. And then the final study, or one of the more recent studies we did, we said, what happens if you expose black and white athletes to hot or cold environments? Because by then we were understanding that the temperature is critically important for performance. And that if you can run better in hot conditions, particularly if you're smaller, you have a huge advantage. Being small gives you a massive advantage in hot conditions, not in cool. And so what we did was we had these guys run, both two groups of African runners and white runners, and we had them warm up in relatively cool conditions for 30 minutes, and then we had them run for continuing as fast as they could. It was a time trial, and we measured their speed and some of their body temperature changes. And you can see that in the cool conditions, the groups are exactly the same. There was no difference. And that was fantastic because we knew we had matched groups with equal running ability. And the only difference was that the one group was bigger than the other. And then we had them repeat the experiment when we exposed them to heat. So we introduced heat at time 35. And what you see then is that in the heat, people run slower. But notice they start to run slow quite early on in the test. After 40 minutes, here you can see they're slowing down. And that's another crucial point to understand about physiology. They don't go like this and then die. They start to slow down. And that, I hope I can show you, is because the brain tells you it's too hot, you must slow down. And it happens long before trouble arises. And that's one of the reasons why it's actually relatively safe to hold marathons in hot conditions. And I don't want to raise that question, that debate, because I know it will be one that concerns you. But look what happened to the white runners. The white runners started very much slower. So the moment they got into the hot chamber, they slowed down. And that's called anticipatory control. And it's because they're bigger. And they will generate more heat. And the brain tells them, if you are to run at this speed here, you will die. So they slow down, and they slow down right from the start. And that's what we call anticipatory behavior. And it's crucial to understand anticipatory behavior. And that is why marathon running is generally very safe, because the brain is there to make it safe. It's not you who make it safe. It's the brains of the athletes that make it safe. And it's an important point to understand. And that we've studied athletes in South Africa competing over a 25-kilometer forced march, fully kitted in full army gear, carrying 20 kilograms on their back and a rifle at 43 degrees centigrade. 43 degrees centigrade. And it's a race, 25 kilometers. And they all finish absolutely safe, absolutely happy. Conditions which are impossible. But they do it because they trained for it and they've got a brain. So, if you get worried then the temperature is 25 degrees centigrade, please, really. Humans are designed to cope with much hotter conditions than 25 degrees. So the smaller size of black athletes allows them to run faster from the outset in hot conditions. And because most races are in fact held in hot conditions, because hot conditions for world-class performance start at 13 degrees. So as soon as you have a race that's 13 degrees or higher, the performance of all the athletes is impaired. And the bigger you are, the worse the performance impairment. So that's what we've found so far. Now the question is, and no one else has done any other work that really adds to that. So that's quite a lot of the evidence that we have at the moment. Right, what about genetic predisposition? And this is a complex field. All I'm doing, I'm going to show you one or two studies to show you that actually people are studying it. And let's go back firstly to understand that we are dealing with two different populations. That the sprinters who went to North America and the Caribbean came from West Africa as part of the disgusting slave trade, which of course was tied to sugar and the British Empire, and we won't go down that route. And the endurance athletes are coming from the east of Africa. So they weren't part of the slave trade and the movement towards West Africa. Yeah, now this is a very complex slide, and it's dated up till about 1998, so it's up to about 2000. And it's an analysis of the 900 best performances in 9 different distances. And it looks at it's 9 different distances, and these are the different countries of origin. So if we start on the left, we see that West Africans have produced 315 of the top 900 performances. But what do they perform well at? 100, 200, 400, 800, and a little bit at 1,500. And what this shows you is that about a third of their performances come in the 100 meters. Well, a third of 315 is 100. So almost 100% of the best 100 meters have been run by West Africans. So it's total dominance. So although you see the blue value, you think it's only 30, it actually is 100% of all 100-meter performances. And then Europe, you'll see, distributes more to the longer distances. And the Kenyans actually go, again, from the steeplechase 5,000, that's their strength. And the 42K these data are very dated because it's completely changed now. And the Kenyans are doing much better at the marathons. And then the other countries, Northwest, Ethiopia, Mexico, and East Africa. And that accounts for 96% of all the world best performances are from those countries. But it shows that there is a distribution which is quite different. And ultimately, we'll be able to explain it, but at the moment, we can only differentiate between sprinters and distance runners. That's kind of what we can do. But it's clearly much more complex because the Kenyans are so dominant at the steeplechase and the marathon. That suggests that we should be looking there at something else as well. Ernest Jochel was actually a South African who went to America and became a very famous physical education teacher. And in South Africa, we call physical education Jochel. So his name is linked. And he wrote in 1944, because he looked at the dominance of sprinting by African Americans, he said serious consideration should be given to the hypothesis that the Negro muscle, in contrast to the muscles of whites, is a superior machine producing from a given amount of fuel more energy and less heat. And I once showed the slide in America and it was almost thrown off the podium because it happened to be Harvard, and to say that is racist, apparently. Well, I don't see it as such, but that was the issue. He is stating that the dominance of one group is so amazing that there must be some biological explanation. And he chose a genetic explanation. He could, of course, have said it was environmental. He chose the genetic, and one really, who knows, maybe we need to explain that. However, one of the problems is, who do you compare who to, you see? So now this is Martin Lell, who you'll know is one of the great Kenyan runners. And let's say we went and studied his genes. And then we wanted to compare him. We must compare him from someone from his local tribe. So we go and say, well, what about Martin Lell's gardener? Why don't we compare him to his gardener? So if we did that, as long as his gardener didn't run, we'd have a good control. Unfortunately, Martin Lell's gardener decided to run. And Dixon Chumba became as good, in fact, better than Martin Lell. So we would have completely missed the point. So it's a real problem. If you have a population where there's so many great runners, unless they've been exposed to the same opportunities, you don't know whether you're dealing with genes or what you're dealing with. We did a study at St. Patrick's High School in Eton, which has produced, as you know, many of the great Kenyan distance runners. And we looked at the relations of the schoolboys, and 72% had a first-degree relative who's a competitive runner, if they were the good runners, whereas the kids who weren't running had many fewer relatives who were runners. Now, of course, that could be environmental, that it could be exposure to a family member who's a great runner may also inspire you to become a runner. So that does not tell you whether there's a genetic difference or an environmental factor. But these are some of the studies that have been done. And mitochondrial DNA you earn from your mother. And in this particular study of elite Ethiopian runners, there was, in fact, no difference. And there have been 4 studies showing no difference in genetics between really good athletes, Kenyan or Ethiopian athletes, and other runners. But there are some which show slight differences. And this is a little more complex study which looks at more of the genes, not the few that were studied there. And what you see here is that there are, in fact, some differences. And the better the athletes, the ones with the higher columns, in the light column there were, in fact, some differences. But what that actually means, we don't know. So there were some differences found between elite Kenyan runners and less good runners, but what they actually mean, we don't know. But to say that there have no genetic difference has been found is not correct. And there's another study which measures the male hormone, the male chromosome. So this is what you get from your father. And again, I know it's very difficult to read that, but there were differences in that the better athletes had a slightly different genetic composition in these particular, what we call haplogroups. So there were differences, but what they mean is really difficult to understand. So my suggestion purely as a biologist, the superior performance of West African sprinters, in my view, has a very strong genetic basis because I think sprinting is profoundly genetically controlled. Whereas I think in long-distance running it's different, and the superior performance of East African runners will, I think, have a less obvious genetic basis. I suspect there is still a genetic basis, but I don't think it is as powerful as in the sprinters. And just to give you an idea of performances that sometimes you really can't explain, I'm just going to show you a American football clip. And let's get it going. And I'll show you who you want to watch.
And that good vision.
I want you to watch this guy here. Sorry, I'll show it again. And he's going to catch the ball, and then he's going to do something which is utterly extraordinary. So watch this guy. He's going to run across here, and now he's going to catch the ball, and now he's got two guys standing in front of him. Now, you may say that's environmental. I don't think so. I think that is just absolutely astonishing. In fact, when he jumps, he gets his feet up to the height of the shoulders. Yeah, you'll see it. There's a repeat.
Well, you don't get style points in the NFL, but that ought to be worth 8. I mean, my goodness, that is...
Yeah, now watch him. Here he comes. Now watch where his feet go to. Look at the height his feet get to. They get to the guy's shoulders. And he lands it.
He nails it. That would have been a 10-0 in the Olympics.
So we've dared South African rugby players to do that. So, you might say that anyone could do that. I'm not sure. Yeah. So my bias is to think that there is a genetic predisposition. Early exposure to running, this has also been studied, and I apologize for the quality of the slides. They're sometimes a little bit difficult to see, but these are studies of different athletes. The C is for controls. Sorry, pressing the wrong button. The C is for controls. The N is for national, and that's international. So these are better athletes, and those are the best. And this is how many ran to school. And you'll see that a high proportion of the better athletes, the international athletes, actually did report running to school, whereas more of the controls you see walked to school or were transported. So there was a difference in early exposure to running in these athletes. Not suggesting that's the reason, but it has been measured, and it does show what people suggest, that if some people are exposed to running earlier, they do seem to do better. And then this is the same in Ethiopian runners. And again, it's difficult to follow. However, you can see that this is the number who run. And you can see the marathon runners, most of them ran to school as children. Whereas the other athletes, very few of them ran. So again, the further the distance you ran, the more likely it was that you actually ran to school. So early exposure, there was some evidence for that. What about running economy, and what do we mean by that? Running economy is the change in oxygen consumption or energy output required as you run faster. And these are two very elastic animals. They bounce along, and they're very efficient. The cheetah and the kangaroo. Now, the kangaroo is really interesting because as it runs faster, it actually costs less energy. And that's because of these huge long tendons that store energy and then allow it to bounce forward. And so it needs most energy when it's running quite slowly, because then its tail's on the ground and so on. But once it gets moving, you can see it costs less energy. So this is a very, very efficient animal. And if we could run faster and use less energy, that would be fantastic. Well, so what are the fun? We've done some studies, and what have they shown? Well, individual reports of athletes, and these are some of the most economical athletes, some Scandinavian. Derek Clayton, the marathon runner who ran at 2:08 in the 1960s, was extremely economical. You can see that at any running speed, let's take 20 kilometers per hour, he used much less oxygen than the Scandinavians. And there were two Kenyans who were even more economical than he was, John Ngugi and Julius Carrera. So there was some evidence in the literature that some of the very best Kenyan runners were incredibly economical, and even more economical than a guy like Derek Clayton, who was profoundly economical. So there does appear to be some difference in running economy, but whether that's an important factor or not, we're not certain. The next factor is the muscle fiber composition different, and are Kenyan runners and East African runners able to produce more energy in their mitochondria? So this is another study from a colleague from Stellenbosch University, and he did muscle biopsies on a group of Caucasian runners and local black runners. And what he showed was that, as we found before, the black runners have fewer type 1 fibers. That means they have more type 2 fibers, and the type 2 fibers are the explosive ones, which allow you to run, perhaps sprint and run a bit faster. And he also showed that when he measured certain enzymes in the muscle, and these are enzymes that actually oxidize lactate, they take lactate and use it as a fuel, and you can see that the higher values were found in the black runners. So there were subtle differences, but nevertheless they were there. And when you're looking for small differences in performance, they might just be quite important. And again, we mentioned that whenever studies are done, they always show that white runners have higher blood lactate levels. And so here are a whole bunch of studies. And every time when people run faster, you'll see the white athletes have higher lactate levels than the black runners. So again, this is a consistent finding for which we really at the present have no real understanding or no explanation. And I'm going to skip that one. This one again shows more enzyme activities, and again showing that the black runners have slightly higher values than the white runners. But so what? So what if you can generate more fuel in your muscles or more energy? What really determines performance? And so I would ask you this question. I'm going to show you this lovely car and ask you, how fast does it go? And there is another view. And the answer is, it cannot go because it doesn't have a driver. And what I've led you up to so far is to the critical point that we haven't discussed the brain. We've kept the brain out, and most exercise physiology, as it's been taught for the last 100 years, has excluded the brain from performance. And so we've looked at muscles and the mitochondria and oxygen, and no one's worried about the brain, because the brain is quite important. So this is a typical picture that is shown to biology students all around the world, and it says what limits the ability to increase oxygen uptake. And the implication is that oxygen is driving your performance, so the more oxygen you can get, the faster you will run. And so it says you've got to have respiration and hearts and peripheral circulation, muscle metabolism. So we were looking at muscle metabolism to try to explain why athletes were of different ability. But what's missing? They're missing the brain. And actually, this animal cannot move. It can't exercise. It cannot increase its oxygen consumption because it doesn't have a brain. And so the brain must always recruit the muscles, which then can be used. So these are the two models. If I've taken that picture, and what it shows is that you need all this apparatus here to generate ATP, which is the chemical that fuels muscle contraction. And then the muscle is able to contract. So the muscle will not contract without ATP. But what people forget is if you give ATP to the muscle, nothing happens. It'll look at it and say, stupid, I can't contract with ATP, I need more than that. And so the old model has always been the more energy you can produce, the faster you'll run. But that's nonsensical because that doesn't work that way. Because that's like having a car and filling it up with petrol. Doesn't go if it doesn't have a driver. And the driver you need is the brain. So the brain releases calcium in the muscle from the part of the muscle, and the calcium drives the contraction. So what really drives this whole process is the brain. It's not driven from that way, it's driven from that way. And once you put the brain in the model, then you need ATP for the contractions to occur, but they don't drive the process. And now when you do that, you have the central model of control, and now you have a real racing car, because now this car can move. And the question then is, what limits the speed of this car? Very simple, the brain of the driver, because he's not going to kill himself. He's only going to drive at a certain speed. And that's what happens in exercise. The brain regulates how fast you're going to exercise, because it doesn't want to kill you. So what's missing on this slide, and now we're going to put it in up here, is the brain's ability to recruit or activate the muscles. Now, as I reach that point, I must tell you that it is absolutely impossible for you to recruit all your muscles. So even when Hugh Jones is running his fastest marathon, and he gets to the finish and he thinks he's done the best possible race he could possibly do, he only recruited 45% of his muscles as he crosses the finish line sprint. Only 45%. Why not 100%? Because if he used 100%, he would have died during the race. And that is the key point. We always have reserve. The brain is always making you run just a little slower than you might. And that's a crucial important point. The system doesn't work the other way, that you can run as hard as you can and then die. It doesn't work that way. The brain regulates your performance by restricting how much muscle you can activate. So that tells us that the great athletes must be recruiting more muscle. So we realized this in the 1990s and came and produced this model of exercise, that the brain, the subconscious brain, integrates a neural response or a brain response throughout the body to all the organs in the body, the muscles, the heart, the lungs, and the metabolism. And so the drive comes from the subconscious brain outwards. And then there is feedback, and those arrows are pointing in the wrong direction, but there's feedback from the peripheral organs to the subconscious brain, and that then changes the response. So I've shown you already, if you heat the athlete, they slow down because they're getting feedback from the skin, which says slow down. And so then that changes the response. And this happens with every stride that you take in running. Every stride, there's feedback and change. Every single stride is changed. There are no two strides the same, because at every moment there's feedback coming back to the brain. And then the brain feeds up to the conscious brain, and you feel sensations, and you get the sensation of fatigue. Fatigue has absolutely nothing to do with the physical state of your body. It is a sensation that your brain produces to limit your performance. That's all. It's mythical. It has no place in reality. Okay. So this model predicts that the number of motor units that you recruit in the muscles is controlled by a complex brain regulation to ensure that homeostasis, i.e. balance, is maintained, and you don't reach a limitation and die as a consequence. So what happens when Haile Gebrselassie runs these races is that his recruitment is not the same all the time. He has more muscle recruitment as he runs faster and less recruitment as he runs slower. So the key to his success is to recruit more muscle near the finish. And the question is then, how does he do that? And what's the biology of that? And is it coming from the periphery, or is it coming from the center? And here's that performance. And this is how he ran his marathon, which is utterly astonishing, that a human being can run at this pace every kilometer. If you look at his pacing, it is unbelievable. Sometimes he runs the kilometers within 1 second of each other. His pacing strategies are absolutely astonishing. And then he speeds up at the end. And he discovered, actually, that if he ran faster here, he would get into trouble. And that's how he got this technique for running marathons. But he knew if he was out by 5 seconds on 1 kilometer, that would blow his whole performance. That's how close he got to perfect homeostasis during the race, perfect control. And to beat the world record, you have to do that. And when people say, oh, we're going to run a 2-hour marathon, just forget it, please. This is perfect running. It's perfect running. He could not go 5 seconds faster. I'm just saying. He couldn't go much faster than that because it was perfect. So there's the finish. So the end spurt indicates the system's regulated, not limited. It's a regulated system. Now I'm going to show you the 10,000-meter World Championships in 2007 when 3 guys, Bikili, Savini, and Matatli, ran together for 24 of the 25 laps. And that is their running speed. It was absolutely matched until the last lap. And then Bikili ran away from the other guys. His running speed went up substantially, as you can notice. So there. And how did he increase his speed? Well, firstly, he took more steps. His step frequency went up, and the other guys couldn't increase his step frequency. So that was the difference. His step frequency went up. Now, the point of that is, where do you change your step frequency? In the brain. That's where it comes from. It doesn't come from the muscles, it comes from the brain. And then this is his key, this is his step length. This is how much power he was producing. And his step length he hadn't managed to maintain his step length when he increased his stride frequency. So he was producing more force, obviously. And that was the key difference. So that is a brain phenomenon. You can see there that he was able to increase his step frequency whilst keeping the step length the same or increasing. And that is the key problem in running. The key problem is you don't want your foot on the ground. You want it in the air. That's the key to running. The foot mustn't be on the ground. In other words, the shorter the time it's on the ground, the better the athlete. And what does that mean? That means you have to produce force, huge amount of force very quickly. And that is the key to great runners. And you hope you've never heard that before, but that is the key. And this is what's happened here. The athlete, Bikili, who wins, is able to increase the power of his muscles and shorten his contact time, whereas the other couldn't do that. The other guys couldn't do that. And the question then is, well, how do you do that? And maybe we don't yet understand. So the increased stride frequency and stride length in the final lap must be due to brain function, and then the heart comes along for the ride. But it's not the heart that makes you run faster. It's the heart comes along after the brain has decided to run faster. And this is a very complex slide, but what it just shows you is that if you're going to run faster, so these people are running slowly, and these people are running fast, this is the contact time. You have to shorten your contact time. That is critical. The whole point about running is your contact time has to come down as you run faster, and therefore the force you produce must go up, because you've got to produce more force to lift this body in a shorter time. And that is the key to great running, is a very short contact time. And the key to endurance is that you don't allow that to change. So the reason you slow down is because your contact time goes up, and you speed up when your contact time gets shorter. So, okay, that actually proves the same. So when we look at an athlete like Haile Gebrselassie, he has to have a whole bunch of things going for him to be a great athlete. It's not just one. And firstly, he has to have a very fast stride frequency and short foot contact time due to extraordinarily powerful skeletal muscles. And I know that. Although we've never studied it, we're getting there. We have the technologies. No one in the world has ever studied. I promise you, his muscles will be as powerful as the most powerful weightlifter. They're just tiny, so you forget it. You don't see. You see this tiny little muscle. You think, how can it produce force? That muscle is unbelievable in producing force. So he has to have that. And then he has to have a heart function to maintain homeostasis. He's got to get the oxygen to the brain, as I'll show you, but he must also get rid of heat. But it's not, the main function is not to provide oxygen to the muscles, is to keep homeostasis. and keep the oxygen in the brain and also to keep the heat down. And his superior lung function, you've got to be able to oxygenate your brain, and I'm coming to that as a real factor. And then his pacing strategy maximizes performance while maintaining homeostasis. So that's a little insight into the factors that explain why he's so successful. But we have focused exclusively on heart function and oxygen consumption. And we said it's got to getting oxygen to the muscles. It's got nothing to do with getting oxygen to the muscles. What we believe, and that's what we tested in the Kenyan runners in Cape Town, was that they oxygenate their brains. Because once you deoxygenate your brain, you will slow down immediately. And you can't afford it. Just as you cannot afford your body temperature to go too high, you cannot afford your oxygen tension in the brain to go down. And that's the thing that we are testing at the moment in the best runners we've been able to study. That the real key to their function of their heart is to oxygenate the brain and keep the brain oxygenated. So when we talk about these changes, I'm not sure that they're critically important. What is important is very strong muscles, which we haven't yet, no one has yet studied. Traditional Kenyan Ethiopian diets, the next factor. There have been a whole bunch of studies, and I'm sorry, I didn't correct the slide. And Kenyan athletes eat a very high carbohydrate diet. And then I put in, oh dear. And you wonder why I put in, oh dear. And those of you not in South Africa will know that I'm promoting a different diet for health. And so that's it. So my point is that the greatest runners in the world may well benefit from a high carbohydrate diet, but that doesn't mean to say everyone benefits from a high carbohydrate diet. And I would just say one thing. There's a paper out in Minnesota Medicine last month showing that marathon runners had more severe coronary artery disease than controls who didn't run, at the same level of coronary risk factors, so-called coronary risk factors. And that's quite frightening. And we, in fact, in 1977, were the first to report coronary artery disease in marathon runners. And the question is, how can you have marathon runners who are doing all this exercise and have got low risk factors have more coronary heart disease than people who don't do exercise? And it's something we have to address. And in my view, it's dietary. It's that people who are eating these high carbohydrate diets and their metabolism doesn't cope with it are at risk. Yeah. So that's my point. And obviously there's going to be a lot of research and ideas about this, but just be warned. The idea that running marathons is going to give your heart health has to some extent been disproved by that study. And I think we don't understand nutrition enough. And I would just make the point that carbohydrates have never been eaten in the concentrations we are eating them today, never in our history. And you would expect some complications as a consequence of that. Yeah. So, but I'm not going to speak any more about that. Okay. But did their ancestors? So I asked one of the Kenyan runners, who in fact holds the world record for the marathon at altitude, he said it in Nairobi. I said, tell me, what did your parents run? And did your grandparents run? He said, yes, they were much better runners than me. So this guy's run at 2:06 at altitude. And I said, how do you know? He said, they used to chase the zebra. Now, that is his true story. Why were they chasing the zebra? Because they wanted to eat it. A zebra, by the way, is not 75% carbohydrate. And my standout favorite person in the world is Jackie Meckler, who won this race, Comrades 5 times, and he's here today, and he's 82 years old. Just get a look at him. He's been eating more protein and more fat and low carbohydrates all his life. And he's going to make 100. Jackie, you heard that. There he is. You could not tell. No. You know, people ask me, and they say, you know, must your brain become less functional as you get older? And the answer is yes, if you eat carbohydrates, because your brain needs fat. Speak to him and ask him tough questions and see what his mental capacity is, eating this dangerous diet all his life. So I hope you don't mind me saying that, Jackie. So, I see there's something behind that. Yeah, there we go. Okay, so the traditional diet may or may not be important. High-intensity training, I think that this is critical, that living at altitude and training as hard as these guys do at altitude has an important effect, and it's not on transferring oxygen to the muscles. I think it's transferring oxygen to the brain. And that's what we've been doing, and this shows one of the Kenyan runners we looked at recently, and we are measuring his oxygenation of his brain when we made them run as hard as they possibly could at sea level. And we were unable to show that the oxygen in the brain went down. Whereas in most other studies that have been done, when you reach peak exercise, your oxygen concentration in the brain goes down. In these guys, it didn't. And that would be a very, very simple explanation for why these guys can run so fast at sea level, because their brains are so well oxygenated that they don't get restrictions. And if you live at that altitude and train at that altitude as hard as they do, I mean, I've been to those altitudes, I can barely walk, and you see these guys running sub 4-minute miles at altitude. It's utterly unbelievable. And they can only do it at altitude if they're oxygenating their brains. That's the key. So when they come down to sea level, it's just amazing for them. It's so easy. Motivation to achieve economic success, obviously this is a massive driver, and they acknowledge it. So here's again another study and showing this is economic reasons for being either a national or international Kenyan runner. And you can see probably over 50% of the drive they describe as being for economic reasons. And there are, of course, other reasons. So economic reasons are obviously very, very important to them. And then what about other reasons? And we'll just go, there's some discarded reasons. I don't think that their energetics, the amount of oxygen they use, or their efficiency is different. They don't have more hemoglobin, which is really interesting because you'd think they train at altitude, they must have a bigger blood volume, and they don't. And then pulmonary mechanics and the lungs are not better, they're not better, so we can discard all those things. But what about their effects on the rest of the world? And this is what this guy wrote. And he said, regardless of the possible existence of physiological advantage in East African runners, belief in European runners that such differences exist creates a psychological atmosphere that can have significant consequences on performance. This is known as stereotype threat and can feature in many sports. So the fact that they are so dominant, not only does it make them more dominant, but it frightens everyone else. And that has to be a huge factor that is under-recognized. But let me finish up now and say where we need to look for the performance differences and where we probably will find them. And reductionism is what I've told you so far. I've tried to reduce their performance into 8 or 7 different categories. And I've said, that you must have more powerful muscles, et cetera, et cetera, et cetera. But that's reductionism. It doesn't see the whole human acting. And so physical fitness, this guy wrote this in 1943, physical fitness cannot be defined. Oh, sorry, let me just go back. Because when I spoke in Kenya some time ago, Mike Boyd was in the audience, and of course he was an Olympic medalist. And he said, Tim, please don't get up and tell us we Kenyans are great runners because they've got thin legs. Because some Scandinavian group had come out and said the Kenyans are great because they have thin legs. So physical fitness cannot be defined nor differences be detected by means of a few simple physiological measurements obtained during limited tests. And that's what I've given you. I've given you limited tests of limited values. To do so results in focusing attention on some erroneous concept. Man is not a pulse rate. We're not a heart rate, a rectal temperature, but a complex array of many phenomena. And into performance enters the baffling yet extremely important factor of motivation, the will to do. This cannot be measured and remains an uncontrollable, quickly fluctuating, disturbing variable, which may at any time completely alter the performance, regardless of physical or psychological state. And that's my feeling. My feeling is that ultimately it's the mind where you make the decisions about how well you're going to perform. And we have to understand that and realize that that's probably the factor. So one of the great runners who broke the mold was Sir Roger Bannister, who on the 6th of May broke the 4-minute mile, which was considered impossible, and it was told that in those days that you might die if you break a 4-minute mile. And he said the following. Now, he was a physiologist at the time, a medical doctor and a physiologist. The human body is centuries in advance of the physiologist and can perform an integration of heart, lungs, and muscles, which is too complex for the scientists to analyze. So here I'm standing here as a scientist telling you it is too difficult, it is too complex to understand, and we have to understand that. But later on he said it's the brain, not the heart or lungs, that's the critical organ, it's the brain. And he had good reason, because when he broke the 4-minute mile, the key player was his coach, and that's Frans Stampfel, the coach. And his coach said many things to him, but he said it's simple, all you have to do is want to do it enough, then go and do it, which is not true. You still have to have the biology. But on the day that Bannister broke the world record, it was a terrible day, and Bannister actually didn't want to run. And the coach came and said to him, you can do it, you can break the 4-minute mile on this day regardless of the conditions, and if you don't, you'll regret it for the rest of your life. And Bannister remembers that's his statement, and he says, I shall always regard the crux of Stampfel's contribution, and on the day of the race, he gave me the self-belief that despite the bad weather, I could break the 4-minute mile, and I believed him. And that was crucial. And I believe that in running, it is the self-belief that you're going to do it today, which is utterly crucial. You can have all the biology you like, but if you don't have that belief on the day, it's not going to happen. And so that's crucial. And here's a very close race between two great runners, Paul Tergat and our own Hendrik Ramala from Johannesburg. He's trained as a lawyer, and he came second in that year. He won it the year before, the New York City Marathon. He was third the next year. And he wrote the following, which I found very, very compelling. And he said, and you know, not many great athletes write these sorts of things, which is unfortunate because it would be nice if they did. What I realize that once the mind accepts anything, the body will respond. If you don't convince yourself that you're going to win, then you aren't going to win it. For New York, I have to tell myself thousands of times that I'm going to win this thing. I've done it before and I must do it again, before the start, at the start, during the race, and at the finish. I have to tell myself that I'm going to win it and that I'm better than the other guys. You have to talk to yourself, otherwise you're not going to win. You have to say, whatever happens, I'm going to win. In my opinion, the person who wins the race has already won it inside the head before the start of the race. And that's the component that it's very difficult for us scientists to measure that. But I think that's the missing component in all the discussions that we have. That's not what we're measuring. We're just measuring the structure of the car and the engine size and the fuel. But we aren't measuring what's actually driving that car, which is the brain of the driver or the athlete. And so we have this concept of the brain regulating performance, and the brain will ask you these questions, as all of you know if you've run. And it may not make the question directly to you. And I must say, this is one funny experience I had. The first Comrades I ran in 1973, I came through Westville, which is about 16 kilometers from here. So I'd already done most of the race. And I came around the corner, and my brain said to me, you didn't tell me there was a hill here. It was as clear as that. And who was talking to me? What was it saying? But that's how complex it is. So here we go. How much work do I have to do? That's what the brain says before you start. You may not consciously think about it, but it actually asks that question. How much work do I still have to do? Have I sufficient energy reserves to finish? The brain has to answer these questions all the time. Will I become too hot? Will my muscles be damaged? How do I feel about all of these? Have I done this before? Can I really go the distance? And then most importantly, can I really run with the East Africans? And the brain has to answer all those questions all the time with each stride that you take. It's going to be asking those questions of you. And we spend so much time coaching the athlete, and we forget that these are actually the real questions that the athlete has to answer. So in my view, and this is simplistic, obviously, the outcome of most sporting events is probably decided by the subconscious brain well before the first step is taken. And the outcome is probably determined by what the athlete really believes. And the reason why you get, in my view, places like Kenya and Ethiopia, which become so dominant, is because the belief systems are absolutely so powerful. And they get strengthened every day because these guys train every day, and all the youngsters are recruited into the system and they train with world champions. And they soon learn, but I can run with a world champion. So when I go and run in the world championships, I expect to run with him, not behind him. And the guy I'm running against, I know he can't run as well as my friend who's the world champion. And I think that is a critical factor. And that is why you get these generations of athletes who are from one country who are entirely dominant. And so I think it's this belief system that is generated. And of course the biology has to be there, but the biology alone will not do it. You have to get the belief system going. And how you do that, and I've no idea. I just think it came by chance that the Kenyans got together in 1984, started training together, and it's just grown from there. So we're almost done. So Roger Banner says, though physiology may indicate respiratory and cardiovascular limits to muscular effort, psychological and other factors beyond the ken of physiology set the razor's edge of defeat or victory and determine how closely the athlete approaches the absolute limits of performance. So it's these other factors that really make the difference, and in my view explain why countries like Kenya and Ethiopia are able to produce such astonishing athletes. So my conclusion is an explanation for the success of the East African runners will be found in the way in which their innate physiology, and I'm not suggesting it's not different, I think they do have some advantages, but the training, the environment, expectations, and genes influence the function of those parts of the subconscious and conscious brains that appear to regulate exercise performance. And I think it is the belief systems that they have generated in their athletes that make them so overwhelmingly successful in this very difficult sport of marathon running. So thank you very much for your attention.